All right, I'd like you to pause the video and take a look at which inequality symbol you would use to complete the statement, so number 1, and to determine if both parts of number 2 are true or false. All right, so do a quick review of the symbols before we go through the solutions here. The inequality symbols. So when it points to the left, notice the pointy side is on the left-hand side here. That is going to be a less than symbol, meaning the number on the left side is less than the number on the right side. If it is pointing to the right, notice it's pointing like an arrow to the right. That means it's greater than. So we say the number on the left is greater than the number or quantity on the right. If it has an extra little line underneath that strict inequality symbol, we then say that it could also be equal to as an extra option. So it not only could be less than, it could also be equal to. So the left side is less than or equal to the quantity on the right. Or our last symbol, the quantity on the left is greater than or equal to the quantity on the right. So let's go back and take a look at number 1. So if you think about what would complete the statement, 34 is less than 89 or 34 is greater than 89. And we know that it would have to be less than, so we want to point our inequality symbol to the left. In the second one, negative 41 is less than negative 92 or negative 41 is greater than negative 92. Well, remember on the number line, when you're dealing with the negatives, just for comparison, you would count and get to negative 41 before you get to negative 92 as you're counting from 0 going out to those negatives. So in terms of which one's smaller, the smaller number is further left. So negative 92 is the one that's smaller. So we would want to complete this statement by saying negative 41 is greater than negative 92, because negative 41 is further to the right than negative 92 on the number line. All right, true or false? So 51 minus 14 is less than 37. Well, let's see. 51 minus 14 is actually 37. So we have to ask ourselves, is 37 less than 37? Well, can a number be less than itself? No, it cannot. So this would indicate a false statement. And finally, with letter B, kind of the same situation here. We have to simplify the left-hand side. So 13 plus 28 is 41. Okay, so when we add those together, we get 41. And that gives us a statement. 41 is, let's see, this one's pointing to the left. So that's left means less. Less than or equal to 41. Well, 41 is not less than 41. But because we have the little line there, that means that it's okay for those to be the same value or equal to each other. So the 41 is less than or equal to 41. So we would consider this to be a true statement. All right, so there's our little inequalities review. And the reason why we are reviewing inequality symbols today is because our new unit is on linear inequalities. So basically, think of it as linear equations, but with an inequality in its place instead. We're going to start out today by looking at solutions of linear inequalities. And our essential question is, how can I tell if an ordered pair is a solution of a linear inequality? So a linear inequality is an inequality in two variables, x and y, whose solutions can be graphed on a coordinate plane using a boundary line and a shaded half plane. So linear inequalities might look like this. Let's see, it could look like this. It could look like this. Or even this. Okay, so basically, if it has an inequality symbol, any one of the four symbols that we discussed in our warm-up, and if it has both of our variables, x and y, that it can be graphed on the coordinate plane, that would be a linear inequality. Now here's a few key components here. When you graph, you are going to get a boundary line. Okay, that boundary line is going to be the location of all of the exact solutions on these inequalities. And then it's also going to be a shaded half plane. So basically, you have your boundary line, and think about what does a boundary do? It takes you right up to the edge of something. And in this case, it takes you right up to the edge of where you have your solutions on one side and your non-solutions on the other side. So each ordered pair is like a test point. So we have the boundary of the solutions and the non-solutions. So here's just kind of a visual that I like that shows for this statement, whether it's y equals 2x minus 4, or y is greater than 2x minus 4, or y is less than 2x minus 4, all kind of represented in the same graph. Now, y equals 2x minus 4 is this line. So all of the ordered pairs on this line would represent solutions to this equation, meaning when I plug in the x value and the y value, the two sides are equal. They're the same. Okay, so that only happens when it's on the boundary line. Now, y is less than 2x minus 4 is all of the ordered pairs that, I guess, think of this as being below the line. All of the ordered pairs below the line, where you plug in the x value and the y value, the y value is less than 2 times the x value minus 4. Okay, so that's all of our solutions to that inequality are going to be on this side of the boundary line. Then we have a different inequality, y is greater than 2x minus 4, that still uses that same boundary line, but when the y value is greater than 2 times the x value minus 4, all of those ordered pairs are going to be above the line up here. Okay, so what we have here is we have our boundary line, and then depending on the inequality symbol, we will have either a shaded half plane above the line or a shaded half plane below the line. So when we're looking at our graphs, a solution is an ordered pair, so an x comma y, like a point on a graph, that is in the shaded area, the shaded region, or it's also a solution if it's on a solid line. Okay, so notice I have here two different types of inequalities graph. One of them that has a solid line, and one of them that has what we call a dashed line. Okay. If the ordered pair lies on a dashed line, it is not a solution. So I have several ordered pairs on both these graphs. Now I want to look at which of these are actually ordered pairs, or excuse me, which of these are solutions. Okay, so a solution would be any ordered pair that's in the shaded region. Okay, so right now I've got two that I know for sure are solutions because it's inside the shaded colored area. Then we also have some points on the line, okay, one on each line. This first point is on the solid line. This other point over here is on a dashed line. Okay, and based on our definitions up here, if it is on a solid line, it is a solution. If it is on a dashed line, it is not a solution. Okay, so I'm going to shade that in green because it's not a solution. And then I have these other points that are on the opposite side of the boundary line as the shaded area. So the shaded area in the blue was kind of above the line. So that means that that ordered pair is not a solution. Same thing over here. If it's not in the shaded area, it is not a solution. So here are some practice problems for you that I would like you to think about. A, B, and C. If you were to plot these 3 points on the graph, would they be a solution or not a solution? Remember when you're plotting points that you want to go in the X direction first. So the first number tells you to go left or right. And then the second number tells you to go up or down and how much. Okay, so pause the video and determine if A, B, or C are solutions or not solutions. And this is 3 problems, not 1. All right, so plotting our 3 points. Point A, so I want to go to the right 2 and up 3. I'll go ahead and label that. And it looks like point A is in the shaded area. Okay, because it's in the shaded region, we're going to go ahead and say that that one is a solution. Point B, -1, 2. So I want to go where x is -1, and I go up to where y is 2. And it looks like point B is right on a dashed line, right on the boundary line. Okay, so remember, boundary lines sometimes are solutions, sometimes are not. So we have to remember that when it's on a dashed line, it is not a solution. Okay, it's only a solution if it's on a solid boundary line, not a dashed boundary line. Okay, point C, we have at -4, -2. So I go to where x is -4, and then if y is -2, I would go down. All right, and I can see that that's clearly not in the shaded side. So that also is not a solution. All right, next we want to look at the actual inequality statement. So a solution is an ordered pair that would make an inequality, like think of it like an equation, like a long statement, but it's an inequality because it doesn't have an equal sign. If it makes it true, okay, so it's a solution if it makes the inequality true, however it reads. For example, here's an inequality, okay, think about what the name of this symbol is. Okay, it's pointing, the pointy side is going to the right, so that's greater than. So y is greater than 1/2 times the x value minus 5. So what I want to do is I'm going to test this point. I want to know, is 0, 0, the origin on the graph, a solution to this inequality, this linear inequality? So I take my x value of 0 and my y value of 0, and I substitute. Okay, so x is 0, y is also 0. I got to do a little bit of math because I can't tell if the left side's greater than the right side yet because I don't know what the right side equals. So I have to do 1/2 times 0, which is 0, and then 0 take away 5 is -5. So I have to think about, is this true? Is 0 greater than -5? So we think about that number line. Okay, -5 would be to the left of 0. So which number is bigger? 0 is larger than -5. So 0 is greater than -5 is a true statement. So we could say that 0, 0 is in fact a solution to that linear inequality. Okay, it is not the only solution because as we saw when we looked at our graphs earlier, the shaded area contains an infinite number of solutions. This just happens to be one of them. So what I'd like you to do is I would like you to determine if the given point, A and B, are solutions of this linear inequality, x plus 2y is greater than 3. So for point A, we have our inequality. Okay, so x plus 2y is greater than 3. And we are going to substitute our values for x and y. So x is 2, y is 3, and I'm just substituting in. And now I want to do a little math. I got to figure out what this left side equals. 2 plus 2 times 3. Well, remember our order of operations say to multiply first. So 2 times 3 is 6, and 2 plus 6 is 8. So is this a true statement? 8 is greater than 3. Yes, that is true. Okay, so we would say that 2, 3 is a solution. All right, so why don't you go ahead and pause the video and try letter B. All right, we're working with the same inequality statement, but we are using different values for x and y. So x is -1, y is +2, and now I need to figure out what is -1 plus 2 times 2. Again, multiply first. 2 times 2 is 4, -1 plus 4 is 3, and we get the statement. 3 is greater than 3. Well, is a number greater than itself? No. So 3 comma 3 is not a solution because that is a false statement. That is not true. All right, that's it for today. Finding solutions of linear inequalities on the graph and also with the linear inequality.